Hello and welcome to the another session of this problem solving in C. In this video tutorial, we will be talking about loop statements. So as a programmer, you may encounter situations when a block of code needs to be executed several times or several number of times. Now when I say several number of times, that means exactly the same statements you need to execute again and again. In general, the statements are executed sequentially. Now when I say sequentially, that means one after another. That means that the first function will be executed, then the second, then the third. Now if suppose the third statement which we are talking about is needed to be executed several times, then we call it as a loop. We'll be using loop statements to do so. Okay. Now programming languages provide various control structures. We have already done about the decision making structures, and loop or repetition statements are one of the control structures which actually reduces the complexity of the complicated execution paths, or number of times you need not to write the same code. So a loop statement allows us to execute statement or group of statements multiple times. Okay, so we can generally say that the loop statement is going to allow us to execute a statement or group of statements multiple times. Okay. So let us see the structure of it. Now it is visible. So the structure will be like whenever we have a condition and till the point the condition is true, we are going to repeat the things in a loop, and one time when it is executed, we again check for the condition whether the condition is true or not. If the condition is true, we are again going to repeat, and then if the condition is false, we will come out of the loop boundary. Now the idea is, suppose you need to write a table of 9, right? So usually what we do, we write 9 ones are 9, 9 twos are 9 threes are, and likewise we go till the okay. That means every time we are repeating the same logic of multiplication, in which one value, this 9 is, this value is constant, and we are only incrementing this 1 2 3 4 5. So we are repeating the same logic 10 times to write a table. Another example of it is, suppose we need to add 5 numbers. Now when we have to add 5 numbers, the addition part, the addition logic is same as we have to add two numbers, right? Number A plus number B. Now if A and B becomes C and I have another number which I wish to add as a third number, then I will write C plus D. This produces, let's say, E. Then I want to add another number, E plus F. So technically in this we are repeating the same logic of adding two numbers, only the value of numbers is changing. So the programming is a very unique way of expressing the intelligence that if you are doing same task, why to write the code multiple times? Why not write a code once and try to repeat the same line of code again and again, rather than having the sequential structures or statements. Okay. As you can see here, this is the flowchart diagram of adding 5 numbers. Now the idea is that as this start and stop, I need not to say it again, and then you have to make certain initialization. Here sum and count are two values which are initialized by 2. Purpose of initializing the value is that you need to perform the addition, the logic of addition in a repeated mode. Then you need to also identify that how many times I have to repeat it. So this count is for the purpose of checking the condition, and sum is the total sum of addition. The idea is this symbol is for input. Here we are inputting the number as n. First we are inputting the number and calculating sum as sum plus n. That means whatever the previous value, we are now adding the new value entered for n. Initially it was 0, so at the first step it will be sum plus n. And then we will increment the count value, count plus 1. And then here comes the part of decision making. This decision making we have already studied earlier, and the decision making helps you to go in either of the direction. If the condition is true, we are getting yes, then we'll follow another way, and if the condition is false, then we will be doing another thing. Now the idea is that we have utilized the decision making here, but we need to keep on repeating this addition processing. This is our processing part. This is the logic. So we are going to repeat this. Once we receive the yes here, we are going to repeat these steps from inputting the value of n, then addition, then increment the counter, and then again check the condition. So here you can see a kind of closed loop part that we started from this point, and then we go back, and then we again came for this decision making. So this is a loop structure. So we have utilized, in this example, we have utilized looping as well as decision making. Once we have entered 5 numbers for addition, which was our aim here in this problem, once we got false here, or we have no here, once we have already done 5 times the addition, then we will be printing the sum. This is again the output symbol, and then we'll stop. So this is the flowchart of sum of 5 numbers. Okay, so I'll just write here sum of 5 numbers. I hope you understand this and it would be very clear that how decision making and looping structures are very much important in programming environment. We will be writing some more codes. Till then, thank you for watching.